This is a great venue. Thank you for having me here. I've been hanging around the JeffConf crew for a while, so some of you may have seen this talk before. If I get far enough, we might do something a bit more interactive than in the past, but we'll see. But basically, the idea here is instead of showing you how to use Lambda or something that already exists, sorry, I'm sick today, so there's going to be some coughing. We're going to try to build something sort of like Lambda or one of these serverless frameworks using some pretty simple libraries and do it in a real kind of bare bones way that you wouldn't really want to do for production. But the purpose of this today is just to show kind of the basic components that go into a serverless framework so that you can understand sort of the process that goes into building something like Lambda and maybe the types of things that are on the back end. Yeah, so I am Bearded Foo because my first name is too hard for people to understand. So if you want to take pictures of me and tweet them, that's where you should tweet them to. If you're wondering how it is I got to be on stage here writing code, it's because I made some pretty confident statements at the first JeffConf I went to, JeffConf London, and Paul Johnston, being the great guy that he is, encouraged me to take action on those. So I saw a lot of people really confused about serverless, and having worked at AWS for a few years before that, I really think a lot of people are overthinking it, so I wanted to show kind of how basic it really could be, which, if anything, is maybe a little bit dangerous, as some kind of Twitter conversations recently have revealed. Yeah, so this is Paul Johnston. He told me I should do it, so now I'm doing it. And in case you're confused about the name, Scrappy, it just means something that really looking at it, you wouldn't think it's quite capable of what it's capable of. And if you look at my code on GitHub, you will definitely get that feeling, because it's not very good. And again, this is just for the purposes of a demo. Don't go trying to run and build some kind of production service on top of this and come crying to me that it's no good, because it's no good. We all know that. We built it on stage. So I have some diagrams here just to get into kind of the basic layout of what I think a basic FaaS system looks like. Usually there's a bit more intro when I do this presentation, but you guys have been hearing about serverless all day long, so I'm going to kind of get right into it. The first step is we take some code from users, we build some images based on top of those. In this case today I'm going to be using Docker images. As calls come in for those different functions that have been submitted, we bring up some kind of temporary infrastructure using those images. We route the requests to the infrastructure that's temporary, and then route the request back to the user. Yeah, so let's get into it. We're going to try to implement this one here. So we're going to try to just accept some code from a user. Is the text size okay in the back of the room? Yep, cool. Okay, so I've got an example file here. It's a world-famous algorithm. Hello world, hello serverless in this case. So we're going to try to submit this code up to the server and get a Docker image built around it. I'm using Python and Flask just for readability, not because they're my favorite or anything like that. I just want to build something that's easy to understand and easy to debug on stage. Hopefully not. Going to get into that, but okay, so in Flask, this is just app.route routes web requests to a particular function, /API/FN is a templated URL in this case, and post refers to HTTP post, which we're going to use curl to submit this code to. So this function takes one argument, which is the name of the function that we're going to be adding, and we're going to build our environment inside of temp. So in this case, I'm going to dump the code into a file called handler.py. And feel free to yell at me if you see me making something that looks like a mistake. This is meant to be interactive, and I'm not embarrassed about writing code on stage and making mistakes, obviously. Okay. So I'm starting here to write a Docker file, which will later on contain the code that's been submitted by the user. Scrappy Serverless is just the name of the image that I've used for the server itself here. So we're going to sort of base the workers on top of that. We're going to keep all of the code that the user has submitted in /worker. So copy the user's code in. There's this really annoying pop-up. Sorry, Visual Studio Code here is trying to help me out. So then the next thing that we need to do, I'm using a system called RQ, which is a very simple queue built on Redis. And this is probably the most confusing bit of this Docker file. I'll finish that off with a new line. So we're going to bring up when the Docker image for the user's code starts up, we're going to bring up RQ's worker, which really just is kind of a very simple Python RPC mechanism. The -u refers to the Redis URL, so we're using some very basic service discovery provided by Docker Compose. -b means burst, so it's going to just grab a job off of the work queue, perform that work, and then close. In this case, fn is the name of the function, so the user submitting the code along with a name, an alias for that code. And fn is the name of that, and that's also the name of the queue. So we're using a queue that's unique to each particular function in the FaaS system. So we're going to do a Docker build. So this is the part of the talk where we start getting into Pylint errors, no doubt. Oh, no way. 10 out of 10, so it's definitely going to work, right? So I have this curl command here, which should take the code from example.py and submit it using sort of an HTML form type submission, and send it to /API/hello with the post request, and we'll see what that does. Okay, so in the code here, you see that I built a Docker file, and then I did subprocess.checkOutput, which is basically just sort of an exec, and returned the output. So we can see the Docker build here happening like you would normally see if you ran it interactively. Looks like it built correctly. So what we need to do now is capture that image ID from the Docker build output. And we're going to use a little bit of Python magic to do that. This is really hacky. If anybody's considering hiring me, this isn't how I build production code. So if we got that right line, we're going to capture the image ID from it. So that should grab the 0, 1 tooth item there, which is the image ID. And we're going to break from the loop. And for those not super familiar with Python, this else on the for loop means that that particular branch gets executed if a break never occurs inside of the for loop. So if we go through all of the output lines and we don't find any successfully built line, it'll raise an exception. Otherwise, it'll set the image ID variable and continue on. Okay, so let's look to see if everything is happy. Seems that it is. And we'll submit that code again. Okay, so now we got back a Docker image ID, which is pretty cool. And we can actually grab that. Oh. And we can see that we have an image that starts in /worker, so that looks right. There is the handler.py file there, and that is indeed the code that we submitted as the user. So far it looks like the image built okay. And we will leave that container. Okay, so we seem to have completed, at this point, this step where we can actually submit the code, and this step where we have built the image based on the user's code. Does this make sense to everybody? Does anybody have any questions up to this point? Okay. So now we'll try to do this part, where we actually bring up some temporary infrastructure based on somebody calling that particular code. And just so it's clear, this is all based on the function name right now, so actually this system theoretically should be able to handle multiple functions. Although it occurs to me, we captured that image ID, but we didn't really save it anywhere. So later on, we're going to have some trouble looking that up. So I'll build a dictionary. And store the image ID based on the function name as the key. And let's just submit that code again to make sure that we don't have any bugs from that. Okay. So now we're going to add another API entry. So this looks really similar to the last one, but there's no methods equals post, which means it's going to be just the default of an HTTP GET. So first we can capture the image ID that was built in the previous step, just looking that up in the dictionary based on the function name. And what we should do now is submit an entry in the job queue. So we're using this queuing system, and the idea is that you would have workers of infinite size, sort of horizontal scaling, and different workers would pull some item off of the queue. So I'm using this system called RQ. It's a little bit strange the way it looks. So we just bring up a queue item for our queue and create a job using the weirdest word in the English language. And inside of that job, we want to call handler.handler. So you'll recall that the function inside of that code was handler, and I dumped it as handler.py. So in this case, this is referring to the Python module handler and the Python function handler inside of that. Okay, so we added an item into the work queue here, but there's nothing that's acting on that. So we're going to use Docker again to have it run in that burst mode. So that's the network name that Docker Compose has given my project. That way we can actually resolve Redis this way. And then we pass the image ID. Docker run network. Seems right. So I'm using repr here, which is kind of like a JSON type thing, but it's pretty Python specific. And that looks right, maybe. Trailing white space on line 68. Helpful as always. So we have to keep submitting the code over and over again because I have this sort of watch exec loop in the background. It's watching me save the files, and then it's taking down the Docker Compose arrangement and bringing it back up. So Redis has gone back down, so we need to submit the code again. Okay. So we submitted the code, and then we actually successfully routed the request into some temporary Docker container. So that's why we see this hello serverless thing here. And we can actually sort of check into this. So you can see that if Docker PS shows that the scrappy serverless system is up and running, as well as Redis, which is running on the same network. But if we look at Docker PS-A, which shows also the things that have stopped, we can see that 20 seconds ago, that worker came up, and you can see that the image ID also matches from the last submission. Yeah, so that worked, but it's kind of boring right now because it's just printing some static string, and that's not really functions. Functions need to take arguments. So the common way these days to take arguments with FaaS systems and things like that is sort of naturally through like a REST gateway or like an HTTP type interface. So we can add that functionality here as well. And we're going to build something in Python known as kwargs, which is just a dictionary of keyword arguments. So there's this kind of funny loop I had to build here. HTTP actually lets you submit with the URL, after the question mark, multiple values. And in the case of Python functions, we're really looking to have just one value passed for every different parameter name. So I'm basically just doing a map there to take whatever the last entry is in the URL for any particular parameter. And we can actually open here. Example.py, and we're going to add a name parameter to this. Okay, so that should default to jeffconf, but if we pass a different username in along with the URL, we should get hello that name instead. And we'll switch back over to this. Scroll back to look for any errors. Looks like everything's okay. So again, Redis is restarted. The database has been cleared, so we have to submit the code over again. Plus, the code has actually changed now. Okay. And let's see if we can call it. We should get hello jeffconf. Okay. That's pretty cool. And let's see if we can pass a different name in as well. Cool. And we get the little U there because of Unicode stuff and Python's inability to handle it. So this is actually the earliest I've sort of gotten to this point, so I think we're going to be able to do something a bit more interactive. So we've accepted code like this. We built some images. We bring up some temporary infrastructure, and we route the result back to the user. And that's pretty cool, but maybe it works for you guys too? Maybe? So let's see here. Okay, is anybody else able to make this work? Actually kind of curious. I see some requests coming in. 404 not found. There's no fave icon. Yeah, so it looks like we did get somebody. No parameter from this one, though. Hello, Brutzel. Who's Brutzel? Pretty cool. Okay, so I don't know, somehow I've actually managed to finish 10 minutes early on this one. Does anybody have any questions? All right. So if you're interested in this type of FaaS and systems, something really simple that you can sort of plug into existing infrastructure like various Docker components and things like that. Don't download my code. Download OpenFaaS. Check that out. I'm not specifically promoting OpenFaaS, but I have got a lot of questions after these in terms of, oh, I really like that type of simplicity with serverless. You know, where can I find that? As far as I'm aware, OpenFaaS is sort of the most compatible one in terms of if this is the type of architecture you'd be hoping for. So if you would like to look at my code and not use it for production, you can find me on GitHub along with this project. Cool. Thank you.